Hey everyone, we just finished up learning how to calculate geographic range. Next up is going to be step 2 in calculating computed visibility, which is to calculate luminous range. Now, in order to do so, we will need two pieces of information: nominal range of the light and meteorological visibility. From before, we know that we get a light's nominal range from the list of lights, the light list, or even on the chart itself. We also know that we can get the expected meteorological visibility from weather reports or other similar resources. Once we have the data, we will then be using the luminous range diagram to determine from those data points what our luminous range is. Before we start, let's talk about a couple definitions. First of all, what is nominal range? Well, Bowditch tells us that nominal range is the maximum distance a light can be seen in weather conditions where visibility is 10 miles. The Coast Guard has made this the equivalent of what they call clear weather. Nominal range takes into account the physical characteristics of the light, such as how powerful or how intense that light is. A light's luminous range is the maximum range at which an observer can see a light under existing visibility conditions. So a different lens of visibility is applied to the nominal range, which will either increase or decrease the distance that we can see the light. The luminous range ignores the elevation of the light, the observer's height of eye, and the curvature of the Earth. Those parameters are used, if you remember, when we calculated geographic range. Now, if the Earth were flat, luminous range would always be your answer to computed visibility for a light. But since it is not, there are times where the geographic range is less than the luminous range, and thus so is your computed visibility. This slide is showing an example of a light with a nominal range of 26 nautical miles. If visibility were 10 nautical miles and geographic range was greater than or equal to 26 nautical miles, we would actually be able to see that light at a range of 26 nautical miles. Now let's say that we applied a lens of visibility of less than 10 nautical miles. The resulting luminous range at which we would see the light would be less. So wait a minute. Some of you might be asking, if meteorological visibility is 10 miles, how can I see a light at a greater distance? Well, that's because meteorological visibility is not the distance at which you can see a light. It is the distance which an unaided eye, meaning no binoculars or anything like that, can see an unlighted object by day. So that value could easily be 10 nautical miles, but because lights burn bright, they can be seen at greater distances. Now, before we do a few examples, let's run through the luminous range diagram. First of all, when you look at the diagram, you need to understand that it's on a logarithmic scale. So this means that the values for both nominal range and luminous range, on the x-axis and y-axis respectively, do not increase or decrease linearly. They start out at very small increments and start to increase very rapidly. Next, the x-axis is the nominal range. This is what we gathered from the light list of lights, or on the chart. These curves are the meteorological visibility curves. These are the lenses of visibility we will be applying to our nominal range in order to determine our luminous range. The diagram shows 9 of them at varying distances. Notice the values that are circled. These are in units of yards and nautical miles. The values below the curves are the metric equivalents. We're going to be sticking with yards and nautical miles, so just keep that in mind. Also notice there are 10 circles with numbers in them, representing the meteorological visibility ranges. While these are important when submitting your weather reports via the JOBS website, I like to cross them off when calculating luminous range so that I don't accidentally confuse one of them for meteorological visibility distance. Here is the chart that correlates to those code numbers from Bowditch. These are going to be the distances, the ranges of your meteorological visibility, and the appropriate code that goes with them. So if you were outside and you estimated meteorological visibility to be between 200 and 500 yards, you would input code 2 into the JOBS website when you submit your weather report. Okay, so back to the luminous range diagram. In this case, we're going to start to do an example. So let's say we have a nominal range of a light of 20 nautical miles. Like I said before, on the x-axis on the bottom or the top, you'll be seeing numbers. Go to where it's 20. I've circled it for you in green. What you're going to do there is you're going to draw a vertical line straight up connecting that same value on the top. Make sure you connect these so that it's vertical, so that when you try to get the intersection point of this and your meteorological visibility curve, your readout for luminous range on the y-axis will be accurate. If it's a little bit slanted, you might connect, for this example, 20 and maybe 19 at the top, and that would actually give you a different number when you got your intersection point of the meteorological visibility curve. So again, just connecting those two values from right from the get-go will help you avoid errors when you're calculating luminous range. So next up, determine your meteorological visibility. In this case, we're going to be given 2 nautical miles of meteorological visibility. So that's that one on red right there. Where they intersect, we're going to place a dot. And then to get luminous range, we are going to draw a horizontal line straight over and read out the number on the y-axis. As you can see here, with a nominal range of 20 nautical miles, meteorological visibility of 2 nautical miles, my luminous range value is 6 nautical miles. Now, nominal range is based on 10 nautical miles of visibility. We discussed that earlier, clear weather. This chart will show you that for any nominal range value you throw at it, if you place that against the point on the 10 nautical mile meteorological visibility curve and read out your luminous range, they should be the same. So let's try it out. Let's say we had a light with a nominal range of 20 nautical miles. First thing we're going to do, find 20 nautical miles on the x-axis, draw that vertical line up, connecting it to 20 nautical miles to the top. Next, we need to find visibility curve of 10 nautical miles. Now, as you notice, those visibility curves that are drawn in are not in standard units. So sometimes your visibility is going to fall in between them. So in this case, we see a 5.5 nautical mile curve. We also see an 11 nautical mile curve. We're saying visibility will be 10 nautical miles. So it's going to be very close, just underneath the 11 nautical mile curve, right about there. Now that we have that, let's draw a point where they intersect. And then let's connect it over onto the y-axis so we can read out our luminous range. Would you look at that? Luminous range happens to be 20 nautical miles, which is equivalent to your nominal range of 20 nautical miles. Again, you can try that out with any value of nominal range. Just place it up against your visibility curve of 10 miles, and you'll see that they are equivalent. This is a good trick and a quick one. If you know or are given a problem where your meteorological visibility is 10 miles or considered clear, there's really no reason to even have to look at the diagram. You should already know that nominal range then would be equivalent to the same value your luminous range would be. Okay, so some problems are going to give you visibility where it falls directly on these standard ranges, the ones that are actually listed on the diagram. In this case, because they're actually there, you should be able to get a very good and accurate intersection point against your nominal range value. So we're going to give you an error of plus or minus 1 nautical mile when you're calculating your luminous range. So let's try an example here. The nominal range of 15 nautical miles, circle that, we'll draw that vertical line straight up, connect it. We're given a visibility of 11 nautical miles. So there's your 11 nautical mile curve. We can see exactly where they intersect, and then we'll draw that out over horizontally. You can see that comes in just over the tick of 15, which puts that luminous range value to 16 nautical miles. Now, because again, this is a standard range of visibility on the diagram, we would allow up to 17 nautical miles and down to 15 nautical miles. Now let's try another one. Let's say it's the same light, so the nominal range stays the same. But let's just say meteorological visibility decreased from 11 nautical miles down to 2. So there's your 2 nautical mile visibility curve. See where it intersects. Let's draw a horizontal line over, read out that value. Luminous range is 5 nautical miles. Again, we would have allowed between 4 and 6. Other times you're going to get visibility that's not equal to one of those standard ranges. It's going to fall somewhere in between. This is where you're going to have to estimate where that curve is, but you've got to use a little bit of common sense to place it in the correct spot. So for this example, nominal range will be 15 nautical miles again. So we'll draw that up vertically, connecting the two values. This time visibility is 7 nautical miles. There's no 7 nautical mile curve listed on this diagram, but we know it falls between that 5.5 nautical mile curve and 11 nautical mile curve. So 1.5 miles above the 5.5 would be the 7. So we know that's not going to be more than halfway between the 11 and 5.5. So we're going to estimate and place that curve. Where they intersect, or where we believe it to intersect, we will place a point and draw that out on a horizontal line. In this case, we've determined luminous range to be 12 nautical miles. Because there is a little bit more room for error on these, since it's not on a standard visibility range curve, we're going to give you plus or minus 2 nautical miles when you're calculating your luminous range. So for this example, we would have accepted anything from 10 nautical miles up to 14 nautical miles.